awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. For A, a 0.03 kg toy car is pushed back against a spring-based launcher as shown in figure 3A. So this is the figure. Okay, means that you push the car and then what happened to the spring? The spring compress and then once you release, the car will move. Okay, so ini berkaitan dengan kalau kita kaitkan dengan conservation of energy. So when you push the car and then the spring start to compress, so akan ada elastic potential energy. Maknanya kereta tu tak bergerak lagi kalau dia compress. Kan? So maknanya you tolak, okay, lepas tu what happen? So what happened to the car when you try to release? So the spring come back to its initial position, initial length, and the car will start to move. Okay, so kereta tu dah akan bergerak lah. Okay, menarik soalan ni. So dia akan ada kinetic energy. Okay, kalau tadi dia ada elastic potential energy before we release the car. So after we release the spring and then the car is moving to the right, so dia akan ada kinetic energy. Okay, so this is the graph of the force required to compress the spring. So means that if you want to compress the spring for 0.02 meter, means that the force required is 5 Newton. Ini grafnya lah. So bila kita ada graph force against X, which is the compression of the spring. Okay, so this is compression of the spring. Okay, actually we can calculate what is the total work done. Okay, the total work done to compress the spring. Okay, question number 1. So you can calculate the area. Okay, area under Fx graph. Okay, so dia akan jadi equal to half times 20, which is the force, and then X is, tengok pada gambar ni lah. Tengok betul-betul gambar ni. Ini sampai sini saja 20. And then this is 0.09. Bukan 0.1 0.09. Okay, 0.09. Alright, and then the answer is 0.9 joule. Okay. So assuming no losses due to heat, what maximum speed is reached by the toy car when it is released? So question number 2 is about conservation of energy. Initial, total energy initial equal to total energy final. Jadi kalau kita tolak kereta tu ke kiri sampai spring tu compress, so before dia akan ada elastic potential energy, and then when the car is released, so we gonna have kinetic energy. So dia akan mula bergerak lah. Masa compress tu kereta tu tak bergerak. Dia compress, U dia kosong lah kat sini. Okay, dia takkan ada velocity because the car is not moving. So dia akan ada half K is the spring constant, Kx squared equal to half mv squared. Okay, so the mass of the car is given. So this one you can cancel out. This one kita ada. We want to calculate V. Okay, tapi kita tak ada K kan. K kita tak ada. Macam mana kita nak cari K? Remember. Okay, kalau kita nak selesaikan macam ni, kita akan stuck lah. Kenapa? Sebab kita tak ada nilai K. Okay. Tapi student kena faham. Okay, awak kena faham. Okay, elastic potential energy. Okay, if we have a graph of F against X, you dah kira the work Okay, this is actually the potential energy U, S. Okay, so daripada sini kita boleh gunalah maklumat kat atas tu. Sebab saya tak ada nilai K. Tapi kalau lah awak kata boleh tak kita nak kira nilai K? Jana, awak rasa boleh tak kita nak kira nilai K? The spring constant.
K equals to Fx kan mana?
F equal to Kx.
Oh.
Okay. Jadi, ada dua cara Ini, let's say lah ini cara yang pertama. Contoh cara yang pertama, awak nak guna, tadi saya katalah, US equal to kinetic energy. US tu awak terus ambil 0.9. Half mv squared. Okay, elastic potential energy equal to work done Work done and then you ambil lah work equal to area under Fx graph. So daripada sini you kira lah V. Boleh juga you nak buat macam ni. So dia akan jadi 2 times 0.9 over the mass. Mass dia tadi berapa? 0.03. So nanti V ni awak dapat lah 7.75. Okay, ini cara yang pertama lah. The first method. Second method, let's say you want to use this one. You want to use half Kx squared equal to half mv squared. Okay. So you can use this. Ini tadi cara yang pertama, you substitute here. Okay. Cara kedua, you need to find what is K. Okay. So kita tak ada nilai K lah. K tu kita tak ada. Awak boleh ambil kat sini lah. F. K tak tahu kan? Ataupun ditukar Kx ni dia akan jadi Fx. Ni. Fx. Where F equal to Kx. So dia akan jadi Fx. Macam tu. Boleh nampak tak yang ni Jana?
Ya, madam.
Okay. Jadi F tu awak pilih lah. Mestilah kita ambil force yang paling besar tu sebab 20. Okay. And then X is 0.09. Okay. X equal to the mass is 0.03 V squared. Cuba kira V. Sama tak jawapan dia? For the second method. This is the first method. Kita ambil terus US tadi 0.9. Or second method, half Kx tu, K tu awak tukar kepada F lah. Since K is F equal to Kx. So berapa you dapat?
Dapat sama madam, 7.35.
Sama Okay, mana-mana cara pun bolehlah ikut mana yang you selesa. Okay. So settle that one. And then question number B B tu saya nak buat kat bawah lah. Okay. So a 10 kg child slides down a 3 meter long slide inclined at 30 degree to the horizontal. Okay. So means that you have a slide here. Okay. Okay. So and then this is 30 degree. Okay. So 30 degree. And then this is the child. Okay. We consider the child sliding down from the top of the slides. Okay. And then the height is not given, but given 3 meter long slide. Okay, maknanya 3 meter tu inilah the green color here. So this is 3 meter. Okay. So I would choose green color. Alright. And then a frictional force of 335 Newton. Okay, means that masa dia nak gerak ke bawah tu, mesti ada frictional force. Given 35 Newton. Okay. So in this case, calculate the speed of the child at the bottom of the slide. Okay, so we want to calculate what is the speed. Masa dia sampai kat sini. V dia berapa. Okay. So, based on this question, okay, bila awak dah biasa buat, kita nak cari, bila soalan nak cari V, and then you boleh kira lah. W is equal to F net S cos theta. Awak boleh kira work, and then you boleh kaitkan work dengan the change of the kinetic energy, work energy theorem. Okay. Jadi untuk yang pertama, macam mana you nak kira W, F net S cos theta? So the second. So for the first one, okay, you lukislah free body diagram. Kan? You lukis free body diagram. So dia akan jadi macam ni lah. Baris. Okay, macam tu. So let's say this is the X component. And the Y component must be 90 degree. Perpendicular to the X component. Okay. Alright. So, the weight of the child should be straightly downward. Sama macam tadi. Straightly downward. So, the angle. Kat mana angle dia? Cepat. Kalau awak nak lukis sini lah. Angle dia ke mana? Inilah kan angle dia. Sekejap. Kalau letak kat sini senang sikit nak tengok. So, ini adalah Y component and this is X component. So, straightly downward here. So, dia mesti rapat dengan Y component. Boleh kat sini? Boleh tak Jana?
Ya, boleh.
30 degree. 30 degree tu rapat dengan Y component. Okay, so saya padam yang ni. Banyak sangat orang dia. Budak dia ada seorang je. Okay. So, the frictional force in this direction. Saya ingat pula. Kejap. So, frictional force in this direction. Lepas tu, itu saja yang ada. Okay, and then kita akan ada W tu kena resolve lah. Okay, W tu you resolve into WX and WY. Okay. And then pergerakan dia ke mana? Dia turun ke bawah. Dia turun ke sini. Dia punya acceleration dia. Okay. So S dia pun ke bawah lah. Dia turun. S dia ini. 3 meter. Dia turun ke bawah. Daripada atas sampai ke bawah ni. 3 meter. Okay. S is equal to 3 meter. So letak sini ataupun nak letak S kat sini pun boleh juga. S is equal to 3 meter. Okay, jadi kalau kita nak kira the work done, so W, okay, the total work done is equal to F net S cos 0. F net tu daya bersih. So daya bersih tu mesti ke sini lah, mesti same direction dengan S. Sebab ada F net yang same direction dengan displacement S, sebab itu budak tu boleh turun sliding down sampai sini. Okay, sampai bottom of the slide. So cos ini adalah cos 0. Okay, cos 0 is equal to 1. But F net tu, macam mana kita nak kira F net? What is the total force F net? Berapa? Apa kita nak tulis dalam bracket tu Jana?
WX tolak F.
Okay, betul. WX. Okay, tolak. WX tu mesti positif lah sebab dia same direction. Dia turun ke bawah macam tu. So WX tu tolak friction. Okay. So kita boleh kira lah. WX is equal to mg sin 30. Okay. Minus friction which is mu n. Friction dia dah bagi 35. Times S is 3 meter. Okay. Cuba carikan berapa work WT.
Dapat 42.15.
42.15 joule So when we use the work energy theorem, sebab kita tahu work energy theorem is equal to kinetic energy final minus kinetic energy initial. So W equal to delta K. So now we can proceed to the second equation where you can use W equal to half mv squared minus half mu squared. Okay, so u equal to 0 lah. Sebab dia start from rest. Okay, we consider start from rest. So W dia tadi, the work done, okay, 42.15. Okay, so dah akan jadi 42.15 half mv squared and the mass is 10 kg. Then finally you can find V, which is the speed of the child at the bottom of the slide. Dapat tak? The answer is 2.9 meter per second. Please check. Dapat tak jawapannya?
Ya, madam, sama.
Sama. Okay, good. Alright, so finish that one. Okay, kita laju lagi lah. So we can try to proceed with the next question. Question number 5 under circular motion. A car drive around a curve with a radius of 400 meter at recommended speed. Okay, means that we have a curve here, the corner. Okay, we consider this is the circular corner. So this is the center. Okay, so let's say you have a car. Okay, so given the speed V is 32 meter per second. Okay, means that it will move in this direction. Speed should be tangential. Okay, kalau kita nak lukis speed, sini lah V dia. Bukan force tau, V. Okay, and then the mass of the car is given. And the radius, okay. So this is the radius, R. Sorry. R. So R is equal to 400 meter. Okay. So now, bila dapat yang soalan macam ini, you must know the concept, okay. The only force that provide the centripetal force in this case is the frictional force. Okay. So friction should be towards to the center. Alright. Dan satu-satunya force yang akan mewujudkan centripetal force adalah frictional force. Satu-satunya force yang akan menyediakan centripetal force adalah frictional force. That's why bila kita tulis total force, total force FC, which is centripetal force equal to MAC. Okay. Dalam kes kereta ni, the only force that provide the centripetal force is frictional force. Okay. So sekarang F kita tu itulah konsep dia. Jadi soalan pertama, calculate the coefficient of static friction. So we want to calculate mu. So actually we can start mu n. F equal to mu n mv squared over r. Okay. So check lah. Kalau ada disediakan tak equation yang penting. Tak ada So awak kena buat sendirilah derive yang tu. Ini kena derive sendiri, kena faham. Okay. So sekarang kita nak cari apa? Kita nak cari mu. Kita ada semua ni. Dan kita tak ada normal force. Bila tak ada, you tengok in your free body diagram of the car here. Okay, we can draw weight downward and then we're gonna have normal force. So ada dua saja force in Y component, which is equal to 0. Okay, which is N plus negative W equal to 0. So the normal force is equal to mg. So if this is equation number 1, so normal force you can calculate straightly lah. Okay, 1400 9.81. Berapa normal force awak kat sini? Kita kira siap-siap. Sebab soalan dah bagi mass.
13734.
Okay.
Bukan point, madam. Terus
saja. Okay.
Madam nak tanya, kenapa Newton tu ke arah N tu ke arah atas?
Dia awak kena tengok pandangan. Bukan, dia macam ni. Dia pandangan 3D dia macam ni. Ini kereta kan? V ke sini. Okay.
Yeah.
Awak punya normal force tu out of page. Weight awak into the page. Ini pandangan daripada atas. Faham tak? the direction of wake is into the page, into the screen. And then you punya normal force ni out of the screen, out of page. Boleh nampak tak?
Oh. Ya, madam. Faham.
Faham dia 3D, dia susah nak tengok. Kalau kita lukis kalau kita tengok daripada tepi tu, okey lah kot. Macam ni kereta awak. Kan? Kereta. So, kalau lah dia pusing in this circular motion. Macam tu. So, kita akan nampak lah V in this direction. Ini awak punya normal. Wake awak ke bawah. Macam tu. Boleh?
Ya, madam.
Boleh tak Jana? Okay. Jadi untuk soalan ni dia bagi mass, then you can find lah normal force. Okay, you can find normal force. But in case soalan tak bagi mass, you tak boleh cari normal force. So you can straightly substitute, okay, equation of the normal force into equation number 1. Untuk cancel mu mg equal to mv squared over r. Kalau soalan bagi mass, awak tak ada masalah nak kira normal force. Tapi kalau soalan tak bagi awak mass, awak substitute saja n equal to mg. So m awak boleh cancel out. Okay, so finally you can find v, where v is equal to mu rg square root. Okay, masukkan dalam equation. Dia nak suruh kira mu Mu is equal to v squared over rg. So V dia bagi tadi 32. Awak check soalan kadang-kadang 32 meter per second tu dia bagi dalam sentimeter per second. So awak kena tukar kepada meter per second. Sama juga dengan radius. Soalan ni mudah lah, dia dah bagi dalam meter. Then you can just substitute all the information given. Okay. So mu kat sini jawapan dia 0.26. Tak ada unit Coefficient of static friction tak ada unit. Dapat tak?
Ya.
Okay, very good. Alright, next. Soalan number 2. What happen if the driver travels at 35 meter per second? If the driver travels more than 32 meter per second, so what happen? And the road is icy. Licin lah. Jalan licin, lepas tu dia bergerak laju 32. Supposedly 32, dia bergerak 35. So what happen? Keyword dekat situ adalah road is icy. Awak tengok kat situ So bila road is icy, okay, jalan itu berais okay. So dia akan jadi slippery lah. Okay. So when the road is icy, okay, means that the coefficient of static friction for the icy road will be smaller than the coefficient of static friction untuk yang jalan biasa lah. Okay, usual road. Alright. Jadi, in this case, if V, okay, the speed ataupun velocity of the car is 35 meter per second, okay, which is if V equal to 35 meter per second, which is bigger than recommended speed. Okay, so kita boleh cakap apa? The car will go into skid. Dia akan tergelincir lah. Sebabnya V tu kalau kita tengok daripada equation, V squared equal to mu rg. Kan? So V is equal to square root mu rg. Sepatutnya bila jalan licin, mu ini akan jadi kecil. Okay? for the IC rod, okay, mu for the IC rod will smaller than mu for the usual rod. Okay. So maknanya V ni, the speed of the car ni sepatutnya dia kena lagi kecil. Tapi kalau kereta tu bergerak melebihi V equal to 35 meter per second, which is bigger than the recommended speed. Okay, so what happen? Sepatutnya dia kena lagi kecil daripada 32. Tapi dia besar pula 35. Sepatutnya V ni dia kena lebih kecil. Okay, V should be okay, smaller. Okay, smaller than 32 meter per second. Okay. And then what happen if V is bigger than 32? So the car will go into skid. Okay, so this is the answer. Boleh faham
Faham, madam.
Okay. Alright, so finish question number 5. Okay, question number 6A. So here we have an object of mass 50 kg suspended from a spring undergoes a simple harmonic motion with a period of 6.0 second. Okay, so T is equal to 6.0 second and the mass is 50 kg. Okay, so ini senang je lah. So we want to calculate what is the angular velocity of the motion. So we can find omega equal to 2 pi over T. This one is very easy, 1 mark only. Okay, so the answer is, you substitute T, so 2 pi over 6, so omega equal to 1.05 radian per second. Dapat masuk formula je lah, yang tu senang je. Okay, and then question number 2. What additional mass should be added to the spring so that it oscillates with a period of 8 seconds? So kalau tadi M1 dia adalah 5 kg, 50 kg, T1 is equal to 6 seconds. So now the question say that, okay, what is the additional mass? Berapa kita perlu tambah? Kan, kalau tadi kita ada spring, so you ada mass M1. And then the oscillation time is 6 seconds. But when M2, okay, for the second part, where M1 plus X kg, kita tak tahu berapa ni kita tambah kan pemberat dia. Ni spring yang sama, dia masih spring yang sama, but this is M2. Di mana M2 ni adalah M1 plus X. So soalan minta additional mass, so dia minta ini. Dia minta kita kira X, bukan minta kira M2. Baca what additional mass, berapa lagi jisim tambahan, mass tambahan perlu kita tambah supaya spring itu oscillate 8 second. So T2 is 8 second. Okay, so in this case, okay, we want to apply equation of T. Okay, the period for the spring, oscillation of the spring. So T is equal to 2 pi square root M over K. So we need to use this equation. Okay. So kita boleh relatekan lah. Untuk yang pertama tadi, okay, for M1, tengok yang pertama M1, kita boleh gunalah T1 equal to 2 pi square root M1 over K. Kalau nak masukkan terus pun boleh. Kan nanti M1 over K. K tu spring constant. Spring constant kita tak tahu berapa. Saya nak tanya awak, spring constant untuk M1 dengan spring constant dekat M2 sama tak?
Sama, madam.
Sama. Okay, pandai. Sama. Sebab dia spring yang sama. Okay. Same value. Sebab dia tak cakap pun dia tukar spring. Dia masih spring yang sama. Okay. So T1 tu you can substitute 6, 2 pi square root M1 is 50 kg over 6. Okay. Kalau awak kata boleh tak saya nak cari K? Boleh, tak ada masalah. Over K. Awak cari dulu K. Berapa? Carikan untuk saya K.
328.99.
Okay. Newton per meter. Okay. And then you can proceed to the second part, which is T2. Okay. So T2 equal to 2 pi M2, okay, over K. So T2 you can substitute 8 second, 2 pi square root. Okay. So banyak sangat ni. Okay. Square root. M2 adalah M1 plus X. Kan? So ini you nak cari X. Over K. K dia adalah 328.99. Cuba selesaikan. Ini you boleh squarekan semua untuk hilangkan square root tu. So dia akan jadi 64 4 pi squared times M1 plus X. M1 tu boleh gantikan lah. M1 tadi 50 kg over 328.99. So boleh cari X. Dapat tak? Cuba kira berapa you dapat X. Therefore, X is equal to berapa? Berapa dapat X?
Dapat 38.89.
38. Sama tak? Mana saya punya jawapan? Okay, samalah. 38.89. Boleh faham soalan ni?
Boleh.
Kena praktis sikit lah yang ni. Okay. Alright, and then kita stop kat sini lah. Awak sambung buat. Cuba sambung buat ni. Ada lagi B, C. Cuba buat sampai habis. Kita boleh habiskan tak kot ni. Sikit lagi. Nombor 7. See you in the next session. Don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.